Okay, so for your information that you will have quiz number 3 tomorrow. So please have a very good preparation to obtain a very good score for the quiz number 3 before having midterm exam in the following week. Okay, so let me share my screen first. Okay, as you can see here, so let me confirm first whether you can see my my slide. Can you see my slide?
Yes, sir.
Okay, and then hopefully my voice is also very clear. So let me share my screen now. Yeah, this is next topic of last week. Last week we talked about correlation and to see the relationship between variable. And today it will be more detailed to see the relationship between variables. So this one that we discussed last week. So today we discussed this one only, right? So the topic today is linear regression analysis. More specifically, we are talking about a simple linear regression. Okay. So perhaps some of you are familiar with this word, regression analysis, right? So this is the way how we see the relationship between two variables. More specifically, in this linear regression analysis, we want to see the effect of independent variable to the dependent variable, right? So in this case, the independent variable is something that is free. I mean, independent variable is something which give influence to the dependent variable, not the other way around, right? So that, for example, if we have an example, right? So let's say independent variable is the study duration, and the dependent variable is your CGPA, right? So that one will be two variable. First variable is, let's say we name it as X, right? And the other variable is, we name it as Y. So here we call it as the independent variable, or IV, and the Y is the dependent variable. So let's say a simple example, say we have X, let's say study duration, for example, study duration, and the dependent variable is your CGPA. So this is a simple example. So in this case, study duration has influence on CGPA, not the other way around. So if you put the other way around, even mathematically you are able to calculate, but the interpretation will be wrong, right? So in this case, we say that Y is the function of X. It means X has influence on Y. So this is in the linear regression analysis. And as I inform you here, it is to explain the impact or influence of the changes in the independent variable on the dependent variable. Okay, this is just like what I have explained to you. Okay, so the relationship between these two variables. Okay, so now we say it in more detail that the independent variable must be specified as X, and the dependent variable must be symbolized by the Y. Okay, so but here, of course, there are many types of relationship between X and Y. But in this course, in this lecture, we talk about the linear function only. We don't talk about the more complicated function. So we talk about only linear function like this, right? Okay, so look at this. This is changes in Y are assumed to be caused by the changes in X, or X has influence on Y, not the other way around. And just like in common statistics understanding that usually we talk about population and sample, right? So let's say here is the population, right? And we take a sample, small portion only. So this one is a sample. So the model, I mean the equation in the population side is like this, right? So as you can see here in the population equation model. So y, which is the dependent variable, is equal to a constant. Okay, that later on we say it is as the intercept. Yeah, intercept plus beta one. Later we say it is as a slope times xi. X is the independent variable plus something that we do not know. That later we say this one is the error term. Error term is something that we do not know, right? So it means here, more specifically, x has influence on y. So in every model, you will have error term, right? So that is why our focus here is to see the influence of the x to the y, or dependent variable. Okay, as you can see here, beta 0 and beta 1 are the coefficient of the model, and epsilon is the random error or error term. So later on, so the equation in the population will be estimated by the equation in the sample. In the sample, we will have equation where this one is y ahead or estimated yi, which is equal to beta 0 hat. Okay, beta 0 hat is estimated value of the beta 0, which is available in the population model, plus beta 1 hat. Beta 1 hat is something that we want to estimate later based on the data we have times xi, right? So this is the what we call the model in the sample size. So later we will see in practice. So again, this one is the intercept, this one will be the slope, this one is the independent variable, this one is the dependent variable, this one is random error. So as you can see here, the relationship between y and x here are a linear function only. So we don't talk about the exponential function, or we don't talk about the more complicated function, but we talk about only linear function, right? So this is the model that we want to estimate later. Okay, so if you refer to this later, because this one is the model in the population side, so later we will estimate beta 0 with a beta 0 hat, right? And we will estimate, or we will calculate the beta 1 by using a beta 1 hat, right? So this is our concern. This is the main problem in the regression model. So basically, what we are doing in the simple linear regression analysis here is that we want to find a function to represent the relationship between x and y. So, for example, if we have maybe let me give you an illustration. So before we go to mathematical function, so let's say we have a data set, just like what we learned last time. So let me just turn off my camera. Okay, let's say we have a data set like this, right? Let's say our data set are pair observation. Okay, let's say this one is the observation number. Assume that what we have is a data set to see the relationship between study duration. Let's say here is x and the other one is y. So let's say x is the study duration, and the y here is your CGPA, for example. So let's say student number 1. So the study duration, for example, study duration in 1 day, let's say 4 hours. And the CGPA is let's say 3.2. And student number 2, we record that the study duration in 1 day is let's say 3 hours. And then the CGPA is let's say 2.9. And student number 3, study duration in 1 day, let's say 6 hours. And then the CGPA is 3.5, and so on. So we have data until an observation, and it is a sample data. Then when we figure it out in a scatter plot, right? let's say like this, in which of course this one should be the X and this one should be the Y. Let's say the pattern is like that. Let's say the pattern of the scatter plot is like this, right? Okay, like this. And the problem in the linear regression analysis is, as you can see here in this scatter plot, there is a pattern. There is a pattern. It seems that when student has longer study duration, tend to have a higher CGPA, as you can see here, because X is the study duration and Y is the CGPA. So in the problem in the simple linear regression analysis is we want to find out a line to represent the pattern of the scatter plot. So what we want to find is only a single line, not a line like this, not this kind of line, because this one consists of many lines like this, right? Not like that. But we want to find out a line that represents the pattern of this scatter plot. So whether the line is like this, I don't think so, right? Whether the line is like that, I don't think so. Maybe not like this, not like this one, right? So it seems that the correct pattern can be represented by this line. So maybe this line, and this line has a function, right? So if let's say I use a symbol with a small letter to make it consistent. Let's say this one is the X, this one is the Y. So the Y here, right? This one is the observation, right? So when we found the line here that represent all these points, so this line has equation that this one is Y hat, because this one is estimated Y is equal to, as I said before, beta 0 hat plus beta 1 hat times the X. Or we can also write it down as Y hat equal to beta 0 plus B0 plus B1X, sometimes like that, right? So in this case, this one is actually the same, so only different symbol. So this is the equation of the line, right? So if you refer to this, right, the Y hat here is actually the points of the Y-axis on this line, right? So how to find this line? That is the problem, right? Of course, we know that the line has this equation. The red line has this equation, but how to find out this line? This line is, can be obtained by using what we call it as ordinary least square. Okay, so this one is the illustration. So assume that the blue point are the points of our data, right? So now we want to find this line, that the line that represent all the points. How to find this line? So the idea is we need to find a line so that the distance between each point here, the distance between the point to the line here is minimum, right? So of course not a single point, but all the points, right? So let's say here the distance between this point to the line is this one, and this is actually the error term. So this is the error term. So maybe for this line has a very small distance, right? Sorry, let's say this this point has a small distance. So for example, we have another one here. So this one is also the another E. Okay, so if I figure it out using let's say another scatter plot to give you an illustration. So the line can be obtained by using this method, right? So let me figure it out again. Let's say these are the point of our data. See here. Okay, let's say I just put here randomly. Sorry, I don't know. This one is a bit long, so wait for a while. It is actually still loading. Okay, can you see my whiteboard? Okay, Okay, I don't know. There is a problem here. So wait, let me just. I don't know. This one is a bit long. So wait for a while. I think this one is just like a problem because I cannot move to another point. Okay, anyway, let me just use this one. Okay. Okay, this one is the X, this one is the Y. I don't know what is the problem with my this one. Yeah, it is not working actually, but it's okay. Okay, so let's say this is the point of our data. Let's say the point is here, point is here, point is here, just as an illustration. So in order to find the line, let's say assume that the line is somewhere here. Sorry, let me just use this one, different color. Sorry guys, I think I have a problem with my whiteboard. So let me just close it, then reopen the new one. So wait for a while. Okay, it is still loading. So basically what we are going to do is there is a distance on the y-axis. For example, this one is the original observation, right? This is original observation. It consists of this coordinate. So this point has a coordinate of, let's say, x2, y2. This one, let's say here x1, y1, right? Because this one is the coordinate. This one also has a coordinate of, let's say, x3, y3, for example. So of course there is a y here. So the error term here, the random error is here is the distance. This is the distance between the y2 minus y2 head. Actually like that, right? So there is a distance here. Okay, so we call it as the random error. Okay, so if the total distance, of the of each point to the line is minimum, then what we find is the best line to represent our scatter plot. So after that is the method that we call it as ordinary least square. So let me go here. Okay, I think it is still loading. I don't know. I think my computer getting very slow now. Okay, let me go back here. Right. So that is the idea. So that by using this method, later we will have the estimate value of the what we call estimate value of the beta 0. So we will estimate this one with the beta 0 head, or maybe in this slide you can use the symbol as beta 0 head or B0, and this one will be estimated using beta 1 head, or sometimes we can also say it as the V1. And then the line, okay, this line has this equation. So this line has the equation of, let's say, y head equal to B0 plus B1 times X, right? So this one we call it as what we call this one as the intercept, and B1 as the estimated slope, right? So this one is the equation. So this one is the predicted or estimated y value for the ith observation, which is equal to the estimated value of intercept plus beta 1 times xi. So this is that previously we symbolized it as the epsilon, right? So in this equation we symbolize it as the EI. So this is basically the epsilon that we discussed before. So look at this, the epsilon here, the EI is here is okay. This is just similar to the one as EI, is the distance on the y-axis between the original observation to the y on the line. Okay, so look at this yi. Sorry, let me just put it here. The yi, right, minus the yi head. Now, yi is actually the y value of that particular observation or the ith observation minus the y value of on the line, right? So this one we simplify the equation, become yi minus. So this one we replace it by b0 plus b1 times x. Okay. Okay, let's continue. Right. So look at this. So this one we call it as the linear least square estimator, because the way how to find the regression line just now, the way how to find the yi head, which is equal to b0 plus b1 times xi, this one is by minimizing the e, right? The e is equal to yi minus yi head, right? So that if you refer to the illustration just now, right, when we have a point, right, point here, point here, point here, our data, so that we have the line here. So from this point and this point, it has the e. So for example here, the distance here we will have e1. The distance here we have, let's say, e2. With the distance here we have e3. The distance here we have e4. So there will be positive, right? This is a positive difference. This one will be negative difference. Negative difference if the line is above the point. Positive difference if the point is above the line. This one will be negative, right? This one will be positive, and so on. When you take the summation, here, it will be equal to 0, right? So here is equal sign. So that if you take the summation, it will be equal to 0, because there will be positive, negative, like that. So that is why we will not able to get the minimum distance, because if you take the summation, it will be equal to 0. So that is why we need to square it. So when we square it, the negative sign will become positive, right? So we square it. So the if you see here, we square it. So we square this difference. After we square it, then we take the minimum. So that minimum sum of square error, minimum of sum square EI will be, we will obtain the baseline. So the baseline can be obtained by taking the minimum distance between the original observation on the y-axis to the estimated y, right? So that is why we call it as least. Least means minimum. Least means minimum. Square, because we need to square the EI. A minimum square, least square estimator that is obtained by minimizing the square of the epsilon I, right? So that is actually the background behind the way how to find out the B0 and B1. So later on we will see how to calculate, how to do the calculation to obtain B0 or beta 0 head, or B1 or beta 1 head. Okay, that is actually after some algebra, right? Some algebra or derivation from here, and we, in the end, what we are going to use is only this one. First, you need to calculate the B1. B1 is calculated from, based on this equation, that xi minus x bar times yi minus y bar, in which here x bar is the average of the x and y bar is the average of the y, divided by this one, the summation of xi minus x bar square, right? So this one is also equal to the correlation between x and y. Look at this. This is the linear correlation, Pearson correlation between x and y. times the standard deviation of the y divided by the standard deviation of the x. And then once you found B1, then you will be able to calculate B0. So the calculation step here, you need to calculate the B1 first before calculating the B0. Because B0 is very simple once you obtain the B1, because B0 is equal to y bar, which is the average of the y minus the B1 that you obtained in the previous calculation times the x bar, right? Okay, so the coefficient of B0 and B1 and other regression result in this chapter will be found using computer, right? But actually you can also, you will be able to calculate easily based on this equation, right? But we will show you the way how to do it in the computer. Okay, so later on, maybe if you do a kind of research in your final year project, right? And maybe you can try to use this kind of equation, for example, or to use this kind of linear regression analysis as the tool for solving some problem related to your research, right? Okay, this model is simple actually, right? Because the equation is like what you see here, very simple equation, but it has assumption. It has requirement to have a valid result. This equation will be valid only if you fulfill necessary assumptions, right? So the assumptions is, right, the first one, the true relationship between x and y are linear, okay? And we found it in the equation. So from the equation, we know that the relationship is linear. And from the scatter plot also, we found that the relationship is linear. So what I mean here, maybe before conducting a regression analysis, maybe you can try to figure it out using a scatter plot to see the relationship between both variables, let's say x and y. So this kind of relationship means linear. Maybe if the relationship is not like that in the scatter plot, let's say maybe the scatter plot is like this. So of course it is not linear, right? So here in this lecture we talk about a linear pattern only. We don't talk about something which is non-linear, like maybe let's say x here, the y here, and maybe the pattern is like that, right? So this one is also not linear, right? So here it is assumed that the form of the relationship is linear. Okay, so the error term here, the the epsilon I are independent of the x values, right? So there is no pattern of the relationship between EI and the x values. So that later on, maybe if you make a plot between, for example, here, let's say epsilon I and the x here, so there is no pattern, must be scattered without any pattern, right? So we say that the epsilon I and x are independent, right? And the epsilon I are randomly distributed around 0 with a constant variance. So, right, so this one is also another assumption, right? So the error term must be randomly distributed around 0. Randomly distributed around 0 with a constant variance. Mathematically, we write it down as the here expected value of EI must be equal to 0. It means the if we plot it using a scatter plot like this, right? Okay, let's say this one is the epsilon I, or let's say epsilon I like this, right? So let's say whatever here, let's say y hat, for example. This one are scattered around 0 without any pattern. So this one is 0. Okay, so with a constant variance. Okay, then later on we call it as homoscedasticity. It means the variance is constant. Look at this, constant without any pattern, and so on. Right. So there is no relationship between error term. So here, no. Between error term are not correlated. So this one are assumption to have a valid linear regression analysis. In practice, what you need to understand is how to find B0 and how to find beta 1, and also the way how to interpret the linear regression equation that we have obtained. So later we will discuss about that. Okay, so let's see. Here is how to interpret the slope and the intercept. Remember that the slope is actually B1 and the intercept is the, sorry, let me just move somewhere here. Okay, the intercept here is the B0. Sorry. Okay, so here, the slope is actually B1 and the intercept is the B0. So B0, if you refer to this equation, right? If you refer to, sorry, let's say I have an equation. Y hat is equal to B0 plus B1 times X. So in this case, B0 is estimated average of Y when the value of X is 0. Look at this. How to interpret the B0? So B0 is the average, estimated average value of Y when the X is equal to 0. Because when the X is equal to 0, it will cancel this one, and you will see that B0 is equal to the Y hat. The Y hat in this case the average, right? Again, B0 is the estimated average value of Y when the value of X is equal to 0. Meanwhile, the B1 is the estimated change in the average value of Y as a result of 1 unit change in X, right? So that is the meaning of the slope. Okay, if you refer to this one, let me rewrite this equation. Okay, let me rewrite this equation. Okay, Y hat is equal to B0 plus B1 times X. As you can see here, so B1 is the estimated change in the average value of Y as a result of 1 unit change in X. So when you change the X to 1 unit, then it will change the Y as much as the value of B1. Later we will see in an example. Okay, let's see, this is an example in our daily life. Let's say we have a case like this. A real estate agent wishes to examine the relationship between selling price of a house, right? Selling price of a house actually. Selling price of a house and its size. So it seems, if you see here, we have two variables. Let's say here the first variable is selling price, and the second variable is the house size. House size, right? Okay, so two variables here: selling price and house size. So let me ask you, between these two variables, selling price and house size, what is the X in this case? So please, anyone, if you have an idea, selling price and house size. Selling price is the X or the Y? Selling price. Can anyone has an idea? Selling price is the X or the Y? Selling price should be the, sorry? Oh, okay. Selling price. So let's think something different. Okay. What, you think here selling price has influence on the house size, or the house size has influence on the selling price? Correct. So the house size should be the independent variable, or the X. the selling price should be the Y. So this is the problem that you need to solve first, because whether you do it manually, whether you calculate it manually or you do it using software, if you wrongly define Y as the X or X as the Y, then all calculation will be completed. All calculation can be done, but of course the interpretation will be wrong. So in this case, the house size should be the X and the selling price should be the Y. So in this case, house size has influence on the selling price. Okay, as you can see here, the Y is the house price is the dependent variable, and the independent variable is the square feet or the house size, right? Okay, so that is the data that we have. So this is the house price and this is the size in square feet. So let's see if the house size, the size of the house is 1,400 square feet, and the price is this one $245,000 US dollars. If the house size is 1,600 square feet and the house price is 312,000 US dollars. So here we have these two variables, and we want to find out the scatter plot of this data, right? Look at this. This one should be the X, and this one should be the Y. And when we create a scatter plot, this is a scatter plot of the two variables just now, right? This is scatter plot. So it seems there is some linear pattern, right? If you talk about the correlation analysis, you can only say that the relationship between the house size and the house price is strong, right? But in linear regression analysis, we will find equation to represent the relationship between the house size and the house price. Okay, let me use a highlighter with a different color so that it will be more clear. So let's say this is the highlighter. So it seems the pattern of the scatter plot is like this. So let me use a different color. Okay. Right? It seems the pattern is like that. So this one will be the regression line. Okay, the pattern is like that. So this one will be the this line has an equation, right? This line has an equation. So the equation of this line is that is what we found, Y hat, which is equal to the estimated value of house price is equal to a constant, or sometimes we call it as intercept as well, plus the slope, let's say B1, times the size of the house. So later we need to know how to calculate the B0, and we need to calculate the beta 1. So that one will be the one that we are going to do. Okay, so maybe you can use a Microsoft Excel actually to do this. So let me just show you. Okay, let's say we have data. Okay, let me just copy this data. Let me bring it to Microsoft Excel. Even manual calculation is possible to do, but I think for this course, because this course is basically as introduction, so that we will show you the way how to do it in using a computer. Just use Microsoft Excel. So just now this one is the Y, this one is the X. Okay, let me make it slightly bigger. Okay, let's say use a bigger size. Okay, as you can see here, right, we have X and Y. So if you refer to the instruction here, okay, and you see the instruction, you need to have a data analysis toolpack as I have shown you last time. So make sure that the data analysis toolpack is already available. If it is not available, you need to activate it first, right? And then, okay, in this Microsoft Excel, let's go to data, and then you will see data analysis. So for your information, that I'm using Microsoft Excel or Microsoft Office 2016. Okay, so make sure that this one is available. Okay, just click here, data analysis, and then you will see regression. Look at this. Can you see regression? Can you see it? Okay, regression, and then just click OK here. Okay, so you are requested to specify the input Y range. So without the column name, so only the value, the range of the Y value. So now you can press the up arrow here, and then you can highlight the values only. Okay, the values only. Then you go back here. And then you highlight the X values. So by pressing this one, the up arrow, then you need to highlight like that. And then you go back here. And then where do you want to put the output? In the new worksheet, for example. So let it be like that, no problem. So let me see what should we do next. Or maybe you can also put label optionally, right? Optionally, you can put a label. Maybe you can also add line plot here optionally. This is not a must, not a much, right? So you can here. Okay, this is a label, then line fit plot. Again, it is not something that you have to do. It is an optional. Okay, so even there is a normal probability plot to check whether our data is normally distributed or not. But it is also optional. Okay, just click OK here. Then look at this. You are given the fitted line plot as well. Okay, maybe I think something wrong with the way how we do, because look at this. If you see the title, this is the value of the Y variable. So let me repeat once again. So something wrong with the way how we do. So let me repeat once again. Okay, so let me go here, data analysis. So look at this. This is a regression. I just press OK. So I think the problem is this, right? Whether we need to put a label or not. Because if we don't put the label, okay. So I think that is the problem. Let me just put here. Yeah, okay. So let me see the difference, guys, because this one will be very crucial. Let me delete this one, right? So especially the label. So look at this. We have a data. So let me just use, let me remove this one so that you will see when I highlight the data. Okay, let me use this one first. Okay, so that let's say I have a data like this, right? I don't highlight anything. Okay, I go to data, and then you go to data analysis. So there is a regression here. Okay, so here you need to specify the range of the Y value. Look at this. So you press label. If you highlight including the column name, then you press label. It means it includes the label here. But if you don't checklist the label, it means you highlight the values only, right? So look at this. If I highlight this one, the values only without highlighting the column name, that is Y, and I go back here, I don't need to select label. The same thing for the X. So I don't need to select label. So this one is needed if you highlight not only the numbers but also the column name, right? So the rest is optional. Just click OK. Okay. So you can see the difference, right? You can see the difference here. So X variable and the Y variable. Okay. Is it clear, students? Is it clear the way how I show you? Okay, so look at this. So this one is the estimated regression line. So this one actually the estimated regression line is in terms of points, so that later you can change it, or you can format it with a line actually. So that is actually the point here are the estimated regression line. Let me check whether I can use the rest or not. Okay, so anyway, let me check what is the value of the B0 and what is the value of B1. Look at this. Okay, if you refer to this, this is regression and so on. Look at this. There is a coefficient. Okay, so in this case, what is the value of B0? Can anyone show me? What is the value of B0 out of these two? What is the value of B0? Sorry, too slow. I mean, the voice is too low.
Is it the 98?
Yeah, correct. So 98 is the B0. So if I bring you here, so maybe this one is very clear, right? So I think as you can see here, that is the B0. That is correct. So this one is the B0, and this one is the B1, right? So the others actually, there are actually a lot of information from here actually, but in this course we will focus on the equation only, right? So the estimated value of house price, or usually we symbolize it by y head, is equal to 98.2483 plus 0.10977 times x. X is the house size in square feet, right? As you can see here. Okay, is it clear on this line? Is it clear?
Yes, sir.
Thank you. Right. So later we will try to interpret this equation, right? So this is the estimated regression equation. So I think this one is very clear. This one is intercept. Actually, the 98 here is actually this one. This one is the value of the B0, and the slope is the gradient. Actually, the gradient here. So this one is delta y divided by delta x. Actually, that one is actually the B1, which is the slope, right? Which is the slope. Right? Okay, so look at this, the way how to interpret. Okay, so look at this B0. Sorry, I think let me put here on the right place. So sorry, I think something wrong here. Okay, look at this, right? The B0 is the estimated average value of y when the value of x is 0, right? Because again, our equation, our estimated equation is y head equal to B0 plus B1 times x, right? So look at this, when the x is equal to 0, when the x is equal to 0, it will cancel everything. So what you have, y head is equal to B0. So B0 is the estimated average value of y when the value of x is 0, right? Okay, so in this equation, as you can see here, so that if there is no house, look at this. When the x is equal to 0, it means there is no house, because the size is 0. It means no house. So beta 0 is, B0 is equal to 98.24. Just indicate that for house within the range of size observed, right? So the portion of the house price not explained by the square feet, right? So it means actually in this case, sometimes regression equation, sometimes we cannot interpret it just based on the equation. Because if this one is equal to 0, actually it means no house, right? It means no house. So this one is just the minimum, right? The minimum house price actually. Let's say if the house size is very small, for example, so the minimum price perhaps is around 98,000. Because if this one is very close to 0, it means very small one. Let's say even very small, so that the house price is around this, right? So maybe the more interpretation will be based on the B1, right? So we will see the next one. Okay, so the B1 value is plus. Look at this, there is a plus sign. It means the correlation between the house size and the house price is positive. So look at this, the correlation is positive. It means if you have wider house, you will have, the price is more expensive, right? So, because the relationship is positive. So first, positive is the positive sign, and the second one is how to interpret this coefficient. So B1 measures the estimated change in the average value of Y as a result of a 1 unit change in X. So in this case, the value of beta 1 or B1 is equal to 0.10977 tells us that the average value of a house increases by 0.10977, this one times $1,000, or which is equal to $109.77 on average for each additional 1 square foot of size. So if the house the house size increases by 1 square foot, right? Then the house price increases by $109.77, right? So that one is the meaning of this. Is it clear, students? Is it clear?
Sir.
Yeah. Any questions? Okay, so hopefully this one inform us that the way how to interpret the linear regression line, especially for the B1, because sometimes interpreting B0 sometimes not reasonable, like what we discussed previously. I give you another example. Okay, I will give you another example that sometimes interpreting B0 is sometimes unreasonable. Let's say I have two variables, right? I believe you know this one. Let's say X is the age of baby born. Let's say age of baby. Let's say between 0, let's say here 0 to 24 months. Okay. So, okay, let's say Y is the what is the Y usually, guys? I believe you know this. What is the Y? What is the Y usually? What is the Y? I believe you know this.
Is it the weight?
Yeah, correct, the weight. So this is very common, whether in Malaysia or in Indonesia. If you have cut from medical center, usually you have a chart like this, right? This one is the age in weeks or in months. This one is the baby weight. Okay. So this one principally using regression. Okay, let's say we have equation that y hat is equal to, for example, let's say 1.8, right? So this one is in kilogram. This one be in sometime in week. This one is in week, or let's say in month is also possible, but usually in a week. Okay, so plus, for example, here is let's say 0.7 times x. Is it clear, guys? So this is the equation. So that if, let's say, you have a brother or you have a relative has a new baby, has a baby. Let's say the age of a baby is let's say 3 months, for example, 3 months. So in this case, right? In this case, the estimated weight of the baby is y hat is equal to 1.8 plus 0.7 times times what? Times 3, right? So you will have estimated baby weight is 2.1. Okay, this whether it is small or not is fine. This 2.1 kilogram, right? This one is 3 months. Maybe I wrongly use this equation. So let's say I put to have a more reasonable value. Let's say I put here. Let's say here I just put here 2.1. So let me put here 2.1. So let me change this one to have more reasonable result. Let's say 2.1 plus 0.7 times 3. So this one will be equal to 3.2 kilogram. Is it clear?
Yes, sir.
Yeah. Okay. So now look at this. When we want to interpret this one, right? So look at this. When x is equal to 0, when h is equal to 0, what does it mean? When h is equal to 0, what does it mean? This one is?
It's the x.
Okay, that is the x, fine. But when h is equal to 0, what does it mean in practice? Is there baby with h of equal to 0? So this one is actually new baby born, right or not?
Yes.
Yeah. Look at this. If we apply that equation to this one, right? To this one is fine. So new baby born, right? So x is equal to 0. So the estimated y is equal to 2.1. It means we estimate here new baby born has average weight of 2.1 kilogram. This one makes sense. Is it clear?
Oh yes. Okay, sir.
Yeah. So this is the way how we interpret. Sometimes we interpret this linear equation must be must be reasonable. Like this, if h is equal to 0, so it means no baby. But of course, we can assume that this one is new baby born. Yes, new baby born has average weight of 2.1 kilogram on average. Okay, that is the way how we interpret this linear regression equation. Okay, there are some exercise for you, right? So maybe this one is related to something in agriculture. So this one is maybe for you to do. You try to practice it using Microsoft Excel to find regression equation, and you try to interpret this and that, right? So let's say here exercise number 1. An agricultural researcher wants to see the effect of fertilizer application on the yield of rice paddy, right? Okay, from 20 samples of farmers, so they collect, they interviewed, for example, 20 farmers. The following data were obtained. So let's say farmer number 1, without giving any fertilizer, okay? If you plant something, you plant rice paddy without any fertilizer, of course it will grow, but maybe the yield is not that good, right? So this one means no fertilizer at all, right? But you can still grow the rice paddy plant, right? Okay, so this is a farmer number 2. They put 50 kilogram per hectare, and they obtain 3.9 tons per hectare, and so on. So here is data from the 20 farmers. So you can try to construct a regression model that relates the fertilizer to the rice paddy yield. Okay, so maybe you can get the plot first and so on. So this is for the exercise at home, right? And then the second one is related to our course, right? Let's say we want to see the relationship between the midterm exam score and the final exam score. So usually we say it as UTS. UTS is ujian tengah semester, mean midterm exam, and here is ujian akhir, mean final exam. So it seems there is a relationship between midterm exam score and final exam score. So this one, they collected 20 random sample of students participating in this course, right? Odd semester, I mean last semester, let's say student number 1, the UTS score is 30. Sorry, this one is very low actually. And then the final exam score is 48. And then the second student also got very low score in the midterm exam. In the final exam also got not good one. But here, if you see, actually it is already ordered. I think, yeah, it is already ordered. So one student got the midterm exam score of 80 and got the final exam score of 82 and so on. So you can try to construct regression model that relates the midterm exam score and the final exam score. So let me show you the first one on it, then the second exercise, maybe you can do it yourself at home. So let me just copy this data and then bring it to the Microsoft Excel. Okay, let me put here, and then the other one is, okay, let me just copy this data. Okay, then let me just put here. Look at this. Sorry, this one in my laptop. This one is actually using dot. Maybe if in your laptop using comma is also fine, but here the format of my laptop is using a dot for comma. Okay, let me just change this one to comma, or maybe let me just use a replace button here. Replace button, I replace the comma with a dot like that. So replace all, and you can see here now it is already replaced. Okay, then just copy here and let me put here. So this one is the X. Okay, this one is the fertilizer dose. Okay, let me make it bigger. And this one is the Y, which is the yield. Okay, which is the yield. So of course, you can also analyze this data with this format. Okay, but if you want to change the format of this data, change the rotation. You can rotate this one. Let's say copy and then paste spatial, and then you transpose it so that you will have something like this. All right, to have a similar thing that we have done before. Okay, so we have X, which is a fertilizer dose, and then Y is the rice paddy yield in ton. Okay, so the way how to do, again, we activate, you go to data first, and then on the right, you can see data analysis. Then here, you can see a regression here. Just press OK. All right, and then you highlight the values of the Y and the X data. Let's say, let me see here. So first, you need to highlight the Y values. Okay, the Y variables. Without specifying the, without highlighting the column name, because I do not checklist the label here. Then for the X variable, just press this arrow, and then I highlight without highlighting the column name of the X. Okay, I go back here, then just click OK. Then we will see this result as well. Okay, this one again, this one is the line actually. So let me see here, maybe trend line here, the linear. Okay, so you can see that is the line, right? So let me just delete this one, whether possible or not, or cannot. Okay, look at this. This is the regression line. Okay, so from here we can see that the B0 is equal to 3.13. Let me highlight this one. And then the X, okay, let me just bring it to the whiteboard. Let me copy it. Then let me go here. Okay. So just go here. Okay, based on this output, sorry, this one is slow again. I don't know what happened with my laptop. Okay, fine. Okay, so based on this result, the estimated regression equation, I mean the estimated rice paddy yield or Y hat is equal to 3.138, let's say until 3 decimal places, plus 0.01, let's say 112 times X. Okay, so in which here X is the fertilizer dose, and then here Y is the rice paddy yield, like that. Is it clear, guys? Is it clear?
Yes, sir.
Okay, thank you. Okay, that is actually what we need to do today. So let me know if you have any questions.